Hello, I'm going to do this exercise and I'm going to do it in parts. So we have this structure and we have a beam. This sign is for, I don't know, two-way slab. I'm not really sure, to be honest. Maybe we'll find it later. So then we will we're going to use these values for L. So 5.5 is going to be L, so L2 is going to be 7.15. So here's 5, here's 5. Maybe I'll draw on top of that. So it's 5 and 5, and then this it's 5.5, and this one is 7.15. And we have the one-way concrete slab. It says here. And so first, check the slab height to avoid deflection calculation. So what you do here, you take so here's beam type 1, which is going to look like this. And for some reason in this calculation you count as a simple support, while if there's the other one will look like this, and this part will be simply supported. Simple. This will be simple support, and this will be fixed. And if you take this, it will be fixed and simple, something like that. And so now we have just this part. It's going to be for and you have a fixed wall like this, and then you check the one-way slab with the height. You already have the height. So D plus H is equal to 35, and we see it's already here in the calculation, but height is equal to 30, and so 0.3 meters. And then you have the length for the first slab, 5.5, and the second slab 7.15. So so then you take the 5.5 and divide by 0.3, and this distance times 0.3, and you see find the value for this. 5.5 divided by 0.3 is equal to 18.33, and then you have the other one is 7.15 divided by 0.3. 7.15 divided by 0.3 is equal to 23.3. And this, you have to check these values against this table, which is, let's see, it's not here, it's this table. So here for the slab, so it's a simply supported beam, so it's 20. So 20 for the first one, this one, 20, and you see it's better than 20, that's cool. 20 is more than 18.33, and then in the second case, go back again, and second case we have end span of continuous beam, or one-way slab continuous. This confuses me slightly, but it's probably true. I'm just thinking of what is what here, but in this case I think I'm going to do the lazy way and just say it's 26, it's probably better to fully understand that. But it's 26, so that's less than this, and that's good, cool. So let's continue with let's do so number 2 here. Find the characteristic and design loads of the slab. So the characteristics are without safety factors, and the design are with. And so we see here here we have the given values of the. And also what's not in here, which it's added here, is that we should add one kilonewton extra for the dead load. So for the slab, so this is this. We have so we have dead load. So it's G is equal to 3.9 plus 1.5 plus the one here that we said before, and this is 6.4, right? 6.4, and the Q, which is this, use public use category C1. And if you check the table that's given, we have that's equal to 3, but that would depend on what type of building it is. But that's 3. So these are the characteristic value with a K here, and the total load with design values for D, would be 6.4 plus times 1.35, the safety factor, and then plus 3 times 1.5, and that's equal to 13.14, I think. 13.14, and that's a QD. And also, if we want to do the long-term Q load, QLT, it's going to be 6.4 plus 0.3 times 3, and that should be 8.2, I think. 6.4 plus 0.3 times 3. Oops, my mistake. Oh, oops. Is that too many? 7.3. Okay. Sorry, I made a mistake, so this is not actually the value. So what we want to see is also again with the C1, so the long-term characteristic load is going to be not that, but is wrong. So we have to check the table of the not this one either. We have to check the table of this one. It's in a huge document, but what I did it was to just copy it from there, and also I did write the QLLTK just right now, and we said we have the category C, the 0.6. The second one is the one. And with that, so then it's not like that. Then it should be plus 0.6 times 3. That would equal to what is it before 8.2. And now we have the values of the design for the slab. Okay, so this is for the slab, so you have the weight of the slab, you have the finished materials, so this is like all this, and what we want to do now with the third part is to find design diagrams for slab between 1 and 2 and 2 and 3. Between 1 and 2 and 2 and 3, slab. Should be right. And so what we have now that we didn't include before, because it's the perimeter wall. So these walls here, and that we didn't do. So so that's what we're going to do now. So we have the same Q. So we have took the first one, the top one here, and now we're doing this one, green type 1, and then we have the Q from before, 13.14 plus 8 times 1.35, I believe. So when we're gonna do the compatibility method to find out, that's what we have to do for this diagram here. So we know this, but we actually don't know the moment here. And we have this situation where it's like this, longer here, and we know that there's a Q. Q is equal to 13.14, and we use the compatibility method in order to because this, I don't know really why it's not like this, but it's not, but it's something like this, and I'll say anything on the other side. It's not like this, but it's something like this. So we want to find out this in the middle here. So we take the moment for this one. So we have the Q, we have the L. So it's Q times, let's see, to the rotation. So the rotation for this one. Sorry about that. Oh no, it actually makes sense. So if you take this one, so it makes it rotate to. That's a good question. Sorry. So the formula is the same for both the relay, to be honest. It's, third divided by 24 EI, and to be honest, so on this side it becomes like this, and this should be. Okay, so I'm not sure if this is the 100% correct, this correct formula, but I'm not sure if this is the way to think about it. So this one, the power down here makes this rotate like this, right? Which is okay. Now I actually got it. So yeah, if there's direction here, so then this would come to this, so they will be positive from this side, right? But for the other side, it would rotate like this, and with the sign convention being, with the sign convention being like this is positive. It doesn't really matter, but we're using that. So that would mean this direction here would be negative. So in this case, it would be minus 24, while the other one would be positive in this case. Q, but this would be L. Yeah, this would be length 1 and length 2 divided by 24 EI. And with this, we have we have this going on being Q times. Oh, I'm sorry, this is for rotation. Yeah, so we see the formula. This is not correct. I realized. That's correct, but it's not. It's not really like that. So yeah, as I said again, it was. I don't know why I wrote Q and stuff like that. This is we're trying to find MB here. So it's MB, and we see the rotation. Yeah, so in this regards, it rotates like this, and this would be minus times L, so L1 divided by 3 EI. Well, in the second case would be plus. This would be minus plus MB L2 divided by 3 EI. Let's go double check. Yeah, these have to be the same, so this is correct. Also, if you see if you have the canonical cases, we have there are different kinds here, right? So they're both rotating in the same way. So it's not 6 EI, for example, which is only 3, but on different sides. Okay, so this is way. I mean, they're probably better. I'm pretty bad with calculus, or like with algebra, I mean. So I will. I did this in more steps than I should because they did fewer steps, but as it sounds so bad, I have to do it in different ways. So what I do is the EI. We don't know this, by the way. It will it will cancel out given that's the same. So and also it wouldn't matter. What does matter there is these numbers. So what I did was just to take first times 3. So and also if you want to show I did so let me make correct. So if I had 24 like this, and just take times 3, we will have 1 here in the first, second, I mean, and then you can see that if you just do the numbers, it would be it's very extremely easy, but it's 1/8, So that's what I did in steps. So I did Q L1 third minus L1. So L1 again is 5.5 MB. So that's that. Now we have that, and now we have MB, and L2 was 7.15 MB minus QL second to the eighth, 7/8. Then again times 8 to get Q. Oh, we have the third, so it's 5.5. What do I? Yeah, 5.5. cube, 5.5 to the third, minus, so the 8 times that, so 8 times that is times 5.5, it's 44, is equal to 8 times 7.15, 57.2 MB here, minus Q, that's 7.153. Then you can just take these, and we remember Q is 13.14, just put it in, and then we actually get, so, and then you add, you can calculate numbers, and then just add, take plus 744, so then we have 44 plus 52, so it's 102, just to be sure, and then you just take another one over the side. So then we reach the MB is equal to 769. And the quicker way to do this, it's one way that's probably correct as well, but they did a bit slower. Well, okay, so now we're back again, and let's do the correct. So we had the value for MB with the compatibility method being 69. So when we're going to draw this, the diagram, it's going to look something like, let's do it longer so it's actually more proportional. This is, actually wrong because, this is longer than this. So it's 69 here, 69. And then we take, it's pretty logical, so it's 5.5, here's 7.15. And, you just take the normal, the moment for the, which is QL2 divided by 8, and do that for the different, the only difference is the L, no, so that we have, again, Q is equal to 13.14 times 5.52 squared, and that will give us, 13.14 times 5.52 divided by 8. Let's do that. Right there. It's wrong. Then and that's 49.7 being, so this is with this one, so we can take the dotted line like this, and we can get here it's so in order to take that we take half of this, which I'll do soon, but so 49.7. In the other case it would be the same, but it would be the 7.15 instead. That's what I want to do before when I still have the formula. 7.15, and in the other case it would be 84. Okay, so 69, so the half of the distance here is the half moon here, so 69 divided by 2 is equal to 34.5, so you have 34.5 minus, so this value 49.7, go down, and that would be 34.5 minus 49.7, so it's a bit messy. So here is 15.2. So it would be the moment diagram will be like this on this side, and here again, half of the distance, 34.5 is the same, minus 84, which is 34.5 minus 84 is equal to minus, minus 49.5. Actually, this is minus and the other one is plus, actually, so I don't think it really matters for so much. So they would look like this. Cool. And with this in mind, we can just make it smaller here. And now we want to do the shear diagram. So now we know that the maximum, the highest bending moment would be, let's see, so actually the lower, it should be here, because if you make it more in scale, it's minus, what did I say, 49.5, minus, plus. So if you go and do shear, we can take the reactions, that we can do as well, but also we have to factor in the rotation. The rotation will change the diagrams like this. So if we have this like this is 5.5, and we said before it's going to be rotation like this. So that would be like this. Would be we see the diagram here, and we see that in MB times L, divided by L, minus MB L. So the smaller here and bigger here, the shear. So we have 69 divided by 5.5 is equal to 69 to 12.55. So we have plus minus 12.55 here. We have plus 12.55 here. So with that, it's going to start being like this. No, sorry, like this, which is supposed to be symmetrical. It's going to be larger like this, something like this, more. So we have to add that. So we have that for that one, and then for the other part, for the slightly longer part, 7.15. It's going to be slightly less. So 69 divided by 7.15 is equal to 9.65. So again, but that it's going to be on the other side. So it's going to be, it's going to be the same. Sorry, so it's going to be minus 9.65 there plus 9.65 there, and then you just do the standard one. So this is you take the reactions or the shear, sorry, and then you have the basic QL divided by 2, and so we have 13.14 times 5.5 divided by 2, so 13.14 times 5.5 divided by 2 is equal to 13.14 times 5.5 divided by 2 is equal to 36.13. So we will have 36.13 here minus 9.65, and also we have the same one here, but opposite. So here will be plus, and here will be minus, plus 9.65, and also for the other part. So this is L1 under QL2. It's going to be 7.15. So, and in this case, it's going to be 46.98. So you have here 46.98. 46.98. And so, and also we had, and that will be for. Oh, sorry, I made a mistake here. So okay, it doesn't matter really. So it's going to be like that, and also because this was for the longer part of 2. So here we take so minus 12.55 plus 12.55, and this is with this we can try to make it to scale. Didn't work as I thought. So again, let's draw a new one and make this slightly more here instead. So here we have, and that's going to be change color to change to the sound. So 36.13 minus 12.55. We have a positive number, and I started it going to look like here. So 23.58 here. And then you have this reactions. So it's a continuous load, so it's going to be something like this. So slightly, did I make a mistake here? No, I don't think so. Maybe. Okay, we're gonna see later. 6.13 plus 12.55. The same. No, I made a mistake, I'm pretty sure. So yeah, this I'm slightly confused to be honest, but so it should be minus, because it couldn't be minus this, because it's different on 36.13 minus 12.55. Some of it makes sense. Oh, sorry, I'm thinking about the reaction. Because 36.13 is equal to minus 48.7. Minus 48.7, and then we have, the 46.98 minus 9.65. Now it becomes, it should be plus, and this should be minus in order to make sense. 46. Sorry, no. Like this, 46 minus, is equal to 37.33. 37.33. And then we're going to take there from to there. So it's this is going to be the total of this is going to be it's going to be minus 56.63. 6.63. Yeah. Sorry, I made a mistake again, and in this case, because the rotation is the other way, so here will be minus minus. Well, otherwise it will be plus plus. Still don't really understand why the diagram says something else, but it will be plus here, so this would actually be bigger, and this would be smaller. So it's not going to be that, it's going to, that's going to be, this is going to be 55-ish, 46.98 plus 9.65 is equal to 56.63. This is slightly not that base. 56.63, and here would be something like 35. It's going to be minus 36.98 plus 9.65. It's 37.33 minus. So this is, and then we see that the maximum moment is 56. The shear is 56.63, and then in the lower part, here minus 48.7. And if we want to see where it's also in the question that we want to see where these points are, right? So in order to do that, we are going to take, so we have again, Q is equal to 13.14. So then we have, so you have to take the maximum here, so 56.63.5 by 13.14 for the first one, right? So it's just, then we'll get distance from here to here. I would believe, 56.63 divided by 13.14. So that's 431. This is for the first part. X02. Oh, sorry, for the second part. 601 we believe that's 23.58, this one, divided by the same, because it's the same Q value. So it's 23.58 divided by 13.14, and that's 1.79 meters from this distance. So 1.79, and in this distance, this distance is 4.31. Checking the answer, 2.84. Mm-hmm. 2.84. That would be, so 4.31 plus 2.84 should be 4.31 plus 2.84 is equal to 715. I guess actually what they did was not doing that one, but they was doing this one, so it's the same at 2.84. So I mean, if they be thorough with this, and I think we can, maybe you should even do both if you